Okay guys, we've already been talking about igneous rocks. Now it's time to move on to our next type of rock, which is sedimentary rock. Alright, just like we did with igneous rocks, with sedimentary rocks we're going to look at three main things. That is how they form, some of their properties, and the environments they form in, or what the rocks can tell us about the environment of the ancient Earth. Let's start with formation. Sedimentary rocks come about when other rocks are weathered. That is, little bits of rocks chip off of them. It doesn't matter what type of rock it is. It could be the weathering of igneous rock, it could be the weathering of sedimentary rock, or it could be the weathering of metamorphic rock. Now, these little sediments that come off due to wind or water erosion, they get compressed and stuck together when they collect. And that's why we a lot of times find them in water, because water will actually carry the sediments to a central location where they can kind of gather up, sink to the bottom, and form the material that will eventually become the rock. So some of the properties of sedimentary rocks is that they are stuck together pieces. If we look real closely, we can actually see the individual little pieces of rock that are stuck together. If they are really, really fine little pieces, sometimes we can't tell without a microscope, but some other types of rocks, like conglomerates, look like huge pieces of gravel that are stuck together. One of the other cool things about sedimentary rocks is these are the rocks that we're most likely to find fossils in. And another thing they do is they evenly spread into different layers. That is, one layer of sediment is put down, and sometimes due to erosion, a different material and another layer will land on top of that. And you kind of create these distinct layers. All right, now the environment that sedimentary rocks forms in is any environment where we're going to find erosion making sediments. So those sediments, once again, small little pieces of rock. Sand would be an example of sediment, silt and gravel also sediment. Now let's talk specifically about how erosion tells us what kind of environment that we're going to actually find these rocks in. All right, so let's think about a river. A river moves very quickly, and so we call that high energy erosion. And rivers can carry large sediments or large particles of rock. Now, when the river slows down, what happens is those larger rocks start to sink to the bottom, and they start collecting up like we would see gravel at the bottom of a river. Now, over time, those layers of gravel will actually start to get compressed together and cement together and form rocks. Like, for example, a rock called conglomerate is actually a bunch of big rock pieces kind of stuck together. We'll see some of those in lab. Now, in bigger bodies of water, like large lakes and oceans, we have low energy erosion. So the smaller particles carried by rivers and streams usually end up dumping into a lake or an ocean. Now, once they hit there, suddenly the energy just drops out of them, and there's not a huge current to carry the small particles. So now the absolute smallest ones that made it through the river are going to sink to the bottom of the ocean or lake and form layers of really fine sediment. And from this, they are going to compress and cement together and form things like limestone, which are really, really teeny tiny pieces that get compressed and form into layers. It's these kind of limestone layers that we find a whole lot of fossils in as well.